Hi, we have the AP Physics 1 past paper 2015. We are discussing free response question section. We have the question number 5 that stands for 7 points. In the question, figure shows the string of one end is the oscillator and the other end is attached to the block as shown in this figure. The string and there is attached block. The string passes over the massless pulley. There is a negligible friction between each four string A, B, C, D side by side as shown in a diagram below. According to this, there are force set up along side by side. Each oscillator is adjusted to vibrate string its fundamental frequency. The distance between each oscillator and the pulley is same. The mass of each block is the same. The fundamental frequency is different. This is the base question. The velocity for the wave is V is equal to square root Ft over m by L. Ft stands for the tension in a string, m by L mass per unit length. That stands for linear mass density. The question is, what is the different about four string as shown, the which result have different fundamental frequency? We know fundamental frequency is F1 V over lambda. Lambda is equal to 2L, and we have the value of the velocity square root Ft over m by L. M by L is stand for mu, linear mass density. Here we can say frequency is inversely proportional to linear mass density because the tension is same, block is same suspended, and the length of the string is same. Linear mass density different mean if it is heavier or the thicker string, then mu is large. If mu is large, fundamental frequency is smaller. And vice versa. If the string is lighter or thinner, the mu is smaller and fundamental frequency will be large. That's the reason that each setup has the different fundamental frequencies. There is difference in linear mass density that causes the different fundamental frequency. Okay, a student graph frequency as a function of inverse linear mass density. Will the graph linear, and how will you arrive at your answer? Graph will be not linear. Graph will be linear if frequency is 1 over mu. That will be the linear graph. But in this case, we have different point. We have the square root on mu. So the square root value doesn't follow the linear pattern. It will be the curve. That's the answer. Next point, the frequency of oscillator connected to the D is changed so that string vibrates second harmonic. View from side string below. Draw the mark label on a point string where the greatest vertical speed. So we have the fig, we have to mention where is the string has the maximum speed or minimum speed from side view. Let's say we say second harmonic mean the string will have two loop. Lambda n is equal to 2L by n is stand for 2 length, lambda 2 is equal to L. Second harmonic mean one node at the middle and two anti-node at the quarter and the 3/4 position. Node are the point which have the zero displacement for all the time. So it will have the velocity 0. All time their vertical velocity is 0. Antinode are the point which show the maximum displacement or maximum amplitude. Hence, they are the point where the speed would be greatest. So minimum velocity at the point node, but the greatest velocity at the point of antinodes. So these are the label valued where he asked where will be the velocity, vertical velocity is maximum. So these are the antinode points where the velocity will be maximum. So that's the solution. If you have any query, kindly ask in the comments. Okay, take care.